All right, so this one gives me a little bit different notation, and I already see one typo here. Let's go ahead with t. Pay attention to the variables that you're given. So we're working on a function named m of t. It inputs t values, and we know it's a linear function. And we know that m of 0 equals 2. So as soon as I see that, and this is really the big thing that this section's all about, is when you see that, how you read it off to yourself. So I say, oh, okay, so I know it goes through the point 0, 2. I know when I input 0, it outputs 2. This is a lot trickier. M of 3 minus M of 1 divided by 2 equals 4. That's not telling me a point. And sometimes I'll see people try and do all sorts of rearranging or figure out how to interpret it as a point, but that's not what you're supposed to get out of that. M of 3 minus M of 1 all over 2. So remember that what I really want to happen is for you to see something like M of 3 and think, okay, that's a Y value. That's the Y value I get when I plug in 3. And M of 1 is the Y value that I get when I plug in 1. So we could call this Y sub 2 minus Y sub 1. And that is, in fact, a rise. So whenever you subtract a Y value from another Y value, you are getting a rise. That's a fair thing to call it. In order to call the 2 the run, and call this whole thing slope, you do have to be a little bit more thoughtful. You have to say, okay, well, this is function notation. So I know that my x2 was 3 and my x1 was 1. Is it true that x2 minus x1 equals 2? And the answer is yes, it is. 3 minus 1 is 2. So that is the appropriate run. So if I stuck some other number under this fraction, it wouldn't be slope anymore. But as long as that run matches with those x values, you really are getting slope. And I was a little tricky here, not really intentionally. I named my function m. That doesn't mean that that's slope, so I'm going to just write slope here so that I don't confuse myself anymore. Okay, so what I really got from this, and this is what I want you to be working on, is that the slope of my function is 4. So my slope is 4, my y-intercept is 2. That means the equation for m of t is slope times t instead of x this time, plus my y value of my y-intercept is 2. And that's my equation. So there wasn't really anything that you had to do for work here. It's just training your brain to read function notation and recognize when function notation is giving you a point versus giving you a slope. So that one was definitely giving me a slope. Okay, I don't think I'm going to graph that one. There's nothing too special going on that I think I need to remind you of. But let's do just one more. So last but not least, n of x is a linear function. So we know that it is appropriate to use like a y equals mx plus b because we're told it's linear. We know that n of negative 1 equals 2. So I'm thinking this line goes through the point negative 1, 2. And then I'm told n of 5 minus n of 2 equals negative 2. So again, this is a lot more cryptic than just n of negative 1 equals 2. You shouldn't be trying to turn this into a point. That's not what it's telling you. It's telling you that n of 5, which is a y value, could be your y2, minus n of 2, which could be your y1, is equal to negative 2. So this literally says a rise is negative 2. If we want to build slope out of this, we need rise over run. So right now, we don't know what our run is. That's keeping us from saying, okay, I have the slope, I can find the equation. But again, this is the power of function notation, is when you write something in function notation, n of 5 is a y value, but written right there is the fact that 5 is the x value. So that's not just a mystery y, that's the y that goes with x equals 5, and n of 2 is the y that goes with x equals 2. So I'm going to say here, okay, well then my x2 is 5, and my x1 is 2, and my run is 5 minus 2, which is 3. So my slope is going to be negative 2/3. I think that might have been the slope of our first one as well. Okay, so what we've got so far is that n of x is equal to negative 2/3 x. We don't know the b yet, so we have two choices right now. One, we could stick with slope-intercept form, and we could plug our point in. What we know is that this point right here is on the line. So if we take this x value and we plug it in here, and we take this y value and plug it in over there for n of x, we've got a true statement, and we can solve that for b. So plug the 2 in for y, or n of x, and plug the -1 in for x, and solve for b. So I'm going to say 2 equals positive 2/3 plus b. And we just need to subtract 2/3 from both sides to get b. But I'm going to simplify a little bit. I'm going to say, okay, well, that's like a 2/1. And then we could multiply top and bottom by 3. So I'm really seeing 6/3 minus 2/3, which is positive 4/3. So putting it all together, I'm going to say n of x is equal to negative 2/3 x plus 4/3. Okay, so there's my answer. For anyone who wants to play around with point slope form, the difference there is you'd have an n of x minus your y value, which is 2, equals your slope, 2/3, times x minus your x value, which is -1. So x minus -1 is an x plus 1. So that's how it would work with point slope form. You just plug your y in on the left, your x in on the right, being really careful with the minuses. Okay, and then we would have a little bit of work to solve. So I think it ends up being about the same amount of work. I'm going to distribute the -2/3. And I'm going to go ahead in the same step and say, well, let's add 2 to both sides as well to set that equal to n of x. So I have a plus 2 over here. Just like before, I'd like to turn that into a fraction. So we're going to multiply top and bottom by 3. And I would say n of x is negative 2/3 x. And then if we combine that negative 2/3 plus 4/3, plus 6/3, I'm getting 4/3. And that's not an equals, that's a plus. All right, so we got to the same equation no matter which way we did it. So use whichever method you like, but there's both of them.